Hello there. I wanted to give you some notes on section 2.2. So go ahead and get started with that. 2.2 is all about functions and graphs. Oops, I'm going to start up here actually. So a couple of things you're going to see is you're going to have a graph and it's going to ask you to tell me over what intervals is it increasing, decreasing, and constant. So what that means, if it's increasing, that means the slope is going to be positive. So as you go from left to right, it's going to be going up. Decreasing means the slope is negative, so as you go from left to right, it's going to go down. And constant, the slope would be 0. So it would be flat at that point. And since it's intervals, that means from one number to another. So you can use the brackets like we did in the last section, or the parentheses. The brackets, remember, mean that it includes that value, and the parentheses means it does not include that value. So let's say we have something like this. Let's do something like that. So it says over what intervals is it increasing? So if you look on here, going from left to right, this is going down. So this is decreasing, and then it changes direction here and starts increasing. So it's increasing from here on. And when you talk about the interval, you're only talking about the x values. So if you look, it's when x is 3 all the way, and it just keeps going to infinity. So we would say it does not include 3, because at 3 it's actually neither increasing nor decreasing. So from 3 to infinity it's increasing, and we never include infinity because it can never actually reach infinity. For decreasing, so this, we always go from left to right, so it goes from negative infinity all the way to positive 3, and it doesn't include either of those values. And then it's constant at 3. So if you could say x equals 3, that would work, but since it asks for the intervals, there are no intervals, so I'll just say none. There are no intervals where it's constant. There's a point at which the slope is constant, but no intervals. So that's what you're going to do for those sorts of problems. Another thing that they're going to ask you to do is to find relative maxima and minima. So that is a maximum, remember, is where it changes direction going from negative to positive. And then a relative minima would be where it changes direction going from negative to positive. Did I say that backwards? This was positive to negative, and this would be negative to positive. So this would be the relative max. It would be a high point on the graph. This would be a relative min. Now if you have multiple things going on, so let's say you have something like this. Let's say you have something here at 3, 2, 1, negative 1, and we'll say at 5, negative 1. Okay, so let's see if something like this. In this case, the maximum value, I mean, it's going to go to infinity, but when we talk about relative maxes and mins, we're talking about places where it changes directions. So this one would be a max, and you can have more than one, so you actually have 2 minimum values where it changes direction. So they will ask you a couple different things. First, they'd say the number at which there is a relative max. Okay, and that means the x value where the max occurs. So like for example here, this point, this maximum point is at 3, 2. So the number at which there is a relative max is when x equals 3. And then if it asks you what is the relative max, that's asking for the y value. So that's going to be at 2. These same questions, if you asked him about the minimum, it occurs at -1, or I'm sorry, +1, 2, 3, 4, and +5. There's a relative min at 1 and at 5. I think in the homework you have to write them as commas, so you would write it like that. And then the relative min is the y value at this point, which is -1. Okay, another thing you're going to be asked to do is to tell if a function is even, odd, or neither. So there is a little definition. In order to be even, f of -x should equal f of x. So if we make all the x values negative, it comes out to the same as the original function. And then for odd, if I plug in a negative value, it ends up being the opposite of the original function. So every sign of the original function becomes the opposite of what it was before. On a graph, an even function would be symmetric with respect to, I'm just abbreviating that, the y-axis. So for example, this, it reflects across the y-axis. Yeah, come back to me.